Greetings and welcome, friends! Today, I believe we're talking about, proving geometric relationships, which, it is Valentine's Day, so it's going to be a wonderful time. And we're going to be writing love letters to geometry when we write a new form of proof called a paragraph proof. But I'm getting ahead of myself, please. Oh, settle down. I'm so excited about this. Writing flowchart proofs, though. Another proof format is a flowchart proof, or a flow proof, which uses boxes, and arrows, to show the flow of a logical argument. Now, that might not sound that great from the get-go, but it turns out we can create, a branching tree diagram that will then, communicate the flow of our logic in a more meaningful way. Whereas a two-column proof is very linear. It's just like, I'm writing a bunch of things, but any given line might not have related to the line directly above it necessarily. So here we go. So each reason is below the statement it justifies. Let's see, a flowchart proof of the right angles congruence theorem is shown in example 1. Ooh, can't wait. This theorem is useful when writing proofs involving right angles. So here's another theorem for you. We could nickname it RACT. Man, nah, probably not. Sometimes I try to abbreviate these ones. I feel like it would be cool if it was wrecked. I don't know, but man, I just got I wrecked this problem, right? So let's look at example uno together here. If I can get this up on the screen. And they'll give us a little actividad in un momento. And you guys are going to see your first flowchart proof, which the book sometimes arranges these flowchart proofs in weird orders, just because they couldn't fit them width-wise on the page, I believe. So notice this. Given angle 1 and angle 2 are right angles, I believe it, let's prove that these angles are congruent to one another. All right, so here our given statements become the a starting branch of our proof, and our end value is hopefully going to be the thing that we're trying to prove. In this case, there's only one given statement. I guess I could have broken that into two if I wanted, but here we go. So in one box, I guess that's somewhat rounded corners. We state our statement, and underneath it we give our reason. And then from that, we were able to make a new statement. So if these are both right angles, then the measures of each of those was 90 degrees. Why? Definition of right angle. And if those are both equal to 90, then they are equal to each other, transitive property of equality. And if their measures are equal, then the angles are congruent, def of Kong. So right angles congruence theorem. I always forget this name, so I'm going to have to practice rememorizing it. Let's make a little two-column proof, and that's one of the things that as you're getting familiar with both of these formats, and then eventually a third format, we're going to be doing problems in multiple forms, so you can kind of see the way they work together. So let's see. I'd start with my givens. So I'd say nope, angle 1 and angle 2 are right angles. Bam. Reason givens. Right, and then I could say measure angle 1 equals 90. Measure angle 2 equals 90. Question, comment? Well, what's odd is that we don't know they're congruent with just that information, but now that we prove it, we'll be able to know that it's true forever. Yeah, you're arguing that this should have been a postulate and not a theorem. Well, based on the current definitions and postulates that we knew, we didn't know this. But now that we've proven it, you'll be able to just say, yeah, I know that because this problem is RACT, right? Right angles congruence theorem. That's why I know that. So now we have a name and a logical flow as to why we know that it's true. But I agree, this one's not the most, amazing in its revelation of knowledge that it's giving us, right? It's kind of like, yeah, that feels obvious, but I guess it's good that someone proved it somewhere. And today, right, we're just proving we're getting used to the formats of proofs, so proving simpler things isn't necessarily a bad idea. So this was trans property, and then I could say the angles are congruent. Right, so notice that with this, it's very linear. I would have argued it would have been perhaps more interesting if they separated out angle 1 and angle 2, kind of had them come together at the end, but that's fine. We'll see some like that in a moment. Def of Kong, by the way. Def of congruence. All right. Oh, man, we haven't even started writing yet, friends. Oh, boy. All right, hey, 2 new theorems coming at you. Now, these are theorems, which means you should not accept their truth without proof. Although I do agree that sometimes these can be like, nah, that just makes sense, and you might not have put it in the category yourself as something that needed proof. So let's see. First is the congruent supplements theorem. If 2 angles are supplementary to the same angle, or 2 congruent angles, then they are congruent to each other. So angle 1 is supplementary to angle 2. Angle 3 is supplementary to angle 2. There's only one value that could be added to this angle's measure that would equal 180. So therefore, that measure would have to be equal, and these angles would have to be congruent, is kind of the logic. And then there's the congruent complements theorem, very similar logic. If 2 angles are complementary to the same angle, so this angle is complementary to that one, and this angle is complementary to that one, then they will be congruent to each other, because if, say, angle 5 is like 50 degrees, a 40-degree angle is the only angle that would ever be complementary to it. So these both would have had to be 40, right? That's the only possibility, and they have to be congruent to each other. So that's kind of my quick verbal logic. Let's see if we can look at example 2. Congruent supplements theorem. All right, man, these take up space. All right, use the given 2-column proof to write a flowchart proof that proves the 2 angles are supplementary. So notice we've got our gimmies. Based on those angles being supplementary to angle 2, I know that by definition of supplementary, they add to 180. It's true for both of those. By transitive property, I could say that this and this are equal because they're both equal to the same thing. And then how did I get from here to here? Yeah, it says subtraction. What were we subtracting to go from here to here? Anyone see it? What could I subtract from both sides of this equation? Yeah, measure of angle 2, right? Subtract that from both sides. I get there. And then to go from equality to congruence, that's, of course, classic. Def of Kong! And hey, guys, check this out. I happen to give you a blank flowchart. You're welcome. You didn't have to draw all these boxes. And in terms of getting used to it, it is going to take a little bit of time to get used to the idea of a flowchart proof. But if I was writing this on my own, I would consider the given information each as being their own starting point on the flowchart. And then I'm going to try to bring all of that information together eventually to conclude what I'm trying to prove. Okay? So if I had 3 pieces of given information, then I could have started with 3 separate givens. Now, you've noticed, and actually even in this 2-column proof, sometimes I will just list all my givens at the beginning of the proof, but other times it might actually make more sense to pull it in as it's more helpful or conducive later. So let's see, for first given, angle 1 and angle 2 are sup, and because of that, I could then say measure angle 1 plus measure angle 2 equals 180 by def of sup. There is a fill-in-the-blank flowchart proof on the test as well, but it's not super crazy. Now, I can't combine that into anything special yet, so I'm going to go back to this branch. So let's see, I'm going to say that angle 3 and angle 2 are sup. Reason, given. And then I know that measure of angle 3 plus measure of angle 2 equals 180. Reason, def of sup. And now notice, this is where like flowchart proofs come a little bit more in handy. These two pieces of information combined let me make a new statement. Namely, measure angle 1 plus measure angle 2 equals measure angle 3 plus measure angle 2. And that's true by either transitive property or substitution. But I'll call it transitive because that's kind of the more classic case. And then we were able to subtract measure of angle 2 from both sides and get measure angle 1 equals measure angle 3 by subtraction property. You got to at least abbreviate out to the T so it doesn't look like subs. And if those measures are equal, then the angles are congruent by def of Kong. Now, the only reason that this proof started going down here rather than over was they ran out of horizontal space. But technically, I could come up with all sorts of graphical arrangements of my flowchart proof, and that wouldn't be a big deal. I just turned airplane mode on, meaning I shut off my wireless mouse. Semi-inconvenient, Mr. Watty. All right, let's see. All right, it's back, I think. There we are. All right, everybody's favorite, words. Man, that's not why I came to math class. I was even tempted to just like open a Google Doc and just like type these. But I'm going to handwrite it. I'm going to suffer alongside you as a true leader of mathematics would. Right, I'm not going to send you into the mathematical fray on your own. So here we go. Another proof format is a paragraph proof, which presents the statements and reasons of a proof as sentences in a paragraph. It uses words to explain the logical flow of the argument. And then here's a couple new theorems. Let's take a look at these. Hey, linear pair postulate. I said that was true earlier today, but you didn't know that it was true. But you will believe it's true when I prove it to you. This is affectionately abbreviated as LPP. Amazing. Linear pair postulate. LPP, yeah, you know me. Linear pairs are supplementary. And then this one I used to call that. But this book actually throws the word congruence in there, and vact is not nearly as cool as that. But yeah, vertical angles theorem basically says that angle 1 is going to be congruent to angle 3, and angle 2 is going to be congruent to angle 4. Yeah, so good stuff, good stuff. This one, I think you guys probably, maybe both of these you would argue, like, I think that makes sense. I think I would have believed that is true even if I was lacking the means of proving it to someone. You might have just been like, hey, it's true because it looks true, friend, which isn't a great reason to believe anything. But nonetheless, here we go. Let's look at example 3. It looks like it's about an airport or something. Am I going to run out of space today? All these proofs taking up space. Use the given paragraph proof to write a 2-column proof of the vertical angles congruence theorem. Actually, before I show you, well, you guys have it in front of you, I guess. Do you guys think you would have a way, could one of you verbally describe how would you prove angle 1 was congruent to angle 7 if you couldn't yet use that theorem? No, I can't take that short of a shortcut yet. We'll actually end up relating them both to angle 6. And 5 and 6 are going to be a linear pair and will be supplementary. 7 and 6 will be a linear pair and supplementary. And then 7 and 5 will have equal measures, right? And then I'd be able to prove congruence. So yeah, so I mean, some of these, like you guys have already identified, feel so obvious that it's almost like I need to like try to, you know, almost like give myself a lobotomy so I know less, so that I then will take the time to prove it properly. So it's articulate, it's specific. It requires clarity and consistency in the way we write these things. Here's a paragraph proof. Angle 5 and angle 7 are vertical angles formed by intersecting lines, so they describe the situation. As shown in the diagram, angle 5 and angle 6 are a linear pair. True story, bro. And angle 6 and 7 are a linear pair, right? So they just kind of gave two statements with the same reason. Then, by the linear pair postulate, angle 5 and 6 are supplementary, and angle 6 and 7 are supplementary. So by the congruent supplements theorem, angle 5 is congruent to angle 7. So they actually even used a shortcut from one of our proofs from earlier today. Yeah, man. Yeah, which, by the way, be careful. We just learned like a whole bunch of proofs today, and so that's going to need us to be knowing of their names. Otherwise, we will unintentionally have to be reproving the same thing over and over again when I don't know the name of something, which is a way to do things. Like if you didn't know linear pair postulate, you could on a test just prove it the long way all over again. And I'd be like, all right, like you took the long way, but there you go. All right, let's see. Let's say angle 5 and angle 7 are vertical angles, VAs. All right. Reason is given. Okay. Angle 5 and angle 6 are a linear pair. That is also given. And I guess I'll throw the fact that angle 7 and angle 6 are a linear pair. LP. At least I allow you guys to abbreviate some. Is also given, right? Ah, blast. You got me covered. Thanks. You got my back. All right. Now, if those are both linear pairs, then by linear pair postulate, this statement I could write as measure of angle 5. Nope. See, I was just going to take the long way instead of using the congruent supplements theorem, which is way better. Let's do that shortcut. Angle 5 and angle 6 are sup. The reason that's true is the linear pair postulate. Welcome, welcome. And then I could also say angle 7 and angle 6 are sup by the LPP. Thank you, sir. And then I believe I could say angle 5 is congruent to angle 7. So there are multiple ways I could have proven this if I didn't know the congruent supplements theorem. All right, and actually, some theorems have been proven many times. In fact, the Pythagorean theorem, the fact that it has the name theorem would suggest to you guys that it needed to be proven. The Pythagorean theorem is the world's most proven theorem with the most unique proofs, as in proofs that aren't the same to one another. I believe it's got over 300 proofs. It's got like a Guinness Book of World Records thing going. President Garfield has at one point proven the theorem. There's all sorts of people that have proven it. So it is possible to find multiple means of coming to the same conclusion in the world of math. Wonderful, wonderful. Let's see. Man, I did do that one last time. Let's just skip on down to example 4. Come on, there we go. Maybe during the class quest I'll have you guys look back at some of the monitoring progress ones. Oh, lots of words today, friends. Remember when math was just numbers? All right, using angle relationships. Find the value of x. So, based on this, angle TPS and angle QPR are congruent to each other. Why? Vertical angles theorem, or as this book calls it, vertical angle congruence theorem. But who wants to call it that? That is so much cooler. And because they are congruent to each other, then their measures are equal by def of Kong. Right? I could say that the measures of these two angles are equal. And then by substitution, I could plug this in for each of those measures and get the equation 3x plus 1 equals 148. Right? I'm just kind of like semi-explaining why I got to this point. And now we get to solve using our old school skills of algebra. 3x equals 147. Divide by 3. Feels like 49, I think. X equals 49, I believe. I think so. Yeah, I don't know. Like, I've actually labeled it both. I'm just grabbing a cough drop here. Yeah, the student was wondering whether or not we should label it 49 degrees. I believe if we labeled it degrees, I don't know, would I end up getting like a degree squared thing showing up? I don't know. I've never gotten super particular about it. I would definitely not mark it wrong, but I believe this is just a number, and then the entire quantity would be measured in degrees. But I'm not super picky about that, and nor articulate about it, as you've noticed. Let's see, example 5, last one. Oh, I thought I got away without having to write a paragraph proof. But look at this lovely, lovely pattern. I think I should actually like copy this pattern and make a tie. Like, see if I could get a tie printed in this pattern. Argyle, is that what it's called? I don't even remember. All right. Given angle 1 is congruent to angle 4, this one to that one, prove angle 2 is congruent to angle 3. Okay, I think we can do that. Sadly, they asked for a paragraph proof, and paragraphs are made up of components called sentences, and sentences are made up of smaller components called words. All right, here we go, friends. Let's do this. I don't even know if my hand knows how to do this. Like, can you write words like this? All right, I'm going to say angle 1 is congruent to angle 2. At least I can use some of my math notation here. Let's see, I'm going to say angle 1 and angle 2 are vertical angles. As shown. As well as... Man, I can't even write words. See, I've like failed. As well as angle 3 and angle 4. All right. I'm going to say that... What do you guys think I could say? What's another good statement to make, maybe? If these are both vertical angles, what could you tell me about them? Even before that. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 by... What's my justification? Vertical angles congruence theorem. Wow. All right. And I believe I can make this jump. Angle... Oh, wait, I already have my given, right? Okay. I think I can just say angle 2 is congruent to angle 3. Do you guys see how? Let's see. Guys, I wrote my given wrong. Oopsies. That's a 4. See? It was a 4 the whole time. Okay, let's see if I can make this chain. Ready? All right, where do I start? let's see. 4 is congruent to 3. Or nope, I started the wrong way. 3 is congruent to 4, which is congruent to 1, which is congruent to 2. Therefore, 3 and 2 are congruent. Even if you couldn't figure out the right chain, the reason is transitive property. Properto of angle congruence. Wow. Lovely. I think I spelled that. I just gibberished it together in the end. But anyways, a paragraph proof is something like this. You can have all sorts of transitional words if you want. You know, such that, you know, therefore, I don't know, things like that if you want to make it more wordy and fancy. But I'm a mathematician. I'm not used to wording it. I'm not a wordamatician. That's not what I got my degree in. But yeah, I'm going to, me and my buddies in real life, we're going to go do some other math problems. Hope you have a great day, friends.